There are two different ways to solve a system of linear equations algebraically. We know that we can solve by graphing, but the first algebraic way that we want to take a look at is substitution. So you should be using this to fill out your notes in your foldable that you should have already created. So when do we want to use substitution? There's two different situations that we would want to use it. The first situation is if at least one variable is isolated in one of the equations. And the very first example that I have in your foldable is an example of this. So if I look over at example 1, we can see in that first equation that the y is isolated. So y equals 2x plus 1. We know what the word substitute means. You know, if I'm out of class, I have a substitute teacher come in and take my place. So that basically is telling us that we're going to be able to take the 2x plus 1, which is equal to y, and we can substitute it in for this y here in this second equation. So instead of negative 4x minus 6y equals negative 22, we would have negative 4x, whoops, not plus, I'm writing plus instead of minus. So minus 6 times y, and since y is 2x plus 1, I'm going to substitute y with 2x plus 1. And I'm putting that in parentheses because I'm doing negative 6 times y, so I need to multiply it times the entire quantity, equals negative 22. And what just happened there is by substituting, we got rid of all y's in this equation, and instead we only have x's, which can allow us to solve for the x. So if I were to distribute that negative 6, we'd have negative 4x minus 12x minus 6 equals negative 22. Combining like terms, we would have negative 16x, and I'm going to go ahead and add the 6 to the other side. So negative 16x equals negative 16. Dividing both sides by negative 16, we get that x equals 1. So we have solved for part of our system, right? We found the x. So now we're going to use that to solve for y. And we can basically take this and plug it back into this equation. We know that y is equal to 2 times x plus 1. So if we know that x is 1, then y equals 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. So y equals 3. So in this case, our final solution, we can write it as a point, 1, 3. That means these two lines, if we were to graph them, would intersect at the point 1, 3. Okay, so that is the first scenario when you would want to use substitution, when one of your variables is already isolated. And like we said, in this case, it was that first equation, your y was completely by itself. But that's not the only time that we could use substitution. The second scenario is if in one of those equations you have a variable whose coefficient is 1. It might not be isolated already, but it's something that could be very easily isolated. So we have an example of that in that second example in your foldable. So here we have x plus 5y equals 4 and 4x plus 7y equals negative 10. Well, if I look at this a little bit closer, I can see that that x coefficient, we'll kind of zoom in on that so we can just focus on it. The x has a coefficient of 1, right? So if I wanted to, I could easily isolate that x. So we could say that x equals, if I were to subtract 5y from both sides, we could say that x equals 4 minus 5y. So now the x is isolated, and it was isolated very easily, which allows us to substitute that quantity in for this x down here in the second equation. So 4 times x is 4 times the quantity 4 minus 5y, plus 7y equals negative 10, and now it's just a matter of combining like terms. So we distribute the 4 first to get 16 minus 20y plus 7y equals negative 10. Negative 20y plus 7y is negative 13y, and I can go ahead and take away 16 from both sides so that it equals negative 26. Dividing both sides by negative 13, we get that y equals 2. So we have solved part of the system. We need to go ahead and find our other variable as well. And it's very easy to do that by plugging y in up here, because we know x equals 4 minus 5y. So in this case, x is going to equal 4 minus 5 times y is 2, so 5 times 2. So 4 minus 10 is negative 6. So x equals negative 6. So our solution here, if we wanted to write it as an ordered pair, is negative 6, 2. Now you can always use substitution, but these are really the best two scenarios to actually use it. When you've already got one variable completely isolated, or if it's very easy to isolate another one because it has a coefficient of 1. So go ahead, get these notes in your foldable, and then you can do as much practice as you feel you need. I recommend doing at least some of them in the practice section on Schoology before doing your skills check, and you can keep cruising through. Let me know if you have any questions.